So today we'll start in continuation with the previous class. That is, we were seeing about the gear trains. So we have just seen about the spur gear and helical gear. Right. So actually, a gear train is also a type of power transmission, as we had discussed in the previous class. Okay. And now what is there is that actually we have so many different types of gears that has been used for several applications. Okay, right. So now let us see about the types of gears. Okay, so the first thing is about the spur gear. Okay, it's about the spur gear which is over here. Okay, this is a spur gear, right? So this is the place for the shaft to be uh, inserted into the spur gear, so that the gear is mounted onto the shaft. Okay, so it can be a driving shaft or a driven shaft. Okay, and now if you look at this, if this is the axis of this gear, okay, then we have this teeth also to be present parallel to the axis of the shaft. So each of these teeth are always parallel, but whenever we take any of this tooth that is there on the shaft, okay, it is going to be parallel to the axis of the shaft. So if that is the case, then it is called as a spur gear. So the next type that we are going to see is about the helical gear. Okay, we shall see about the helical gear. Right. So in a helical gear, what do we have? So helical gear, if we take up, so yes, for all the gears, first thing is that it will have a centrally drilled hole for the gear to be mounted onto the shaft. Okay, so here we have the axis. Okay, here we have the axis. Okay, right. Now if you look at this, each of these tooth or the teeth are present on this gear is not parallel to the axis, right? It's not parallel to the axis of the shaft at all. It is at particular angle. So in this particular case, then this type of gears are called helical gears, right? Okay, right. So the next thing that we will see is about the rack and pinion gear. Okay, in a rack and pinion gear, what do you have? So actually, a rack and pinion gear is meant to transfer power. Okay, between where we want to convert rotatory motion into linear motion, or the vice versa, linear motion to rotatory motion, right? Right. So what is going to happen over here is that, so we have a track which is called as the rack over here. Okay, just like a railway track, a parallel thing. So on which there is the teeth that is present parallel to each other over here. Okay, upon which a spur gear is going to be used, which will be mounted on a shaft. Okay, so when this gear is going to rotate, now let us assume that the shaft, this is going to be in the same place, one condition, okay, and this rack can move linearly. So if the gear is going to rotate, then it is going to move the rack because both of them are in contact. Okay, so what is going to happen if this is going to rotate, if the gear is going to rotate in anti-clockwise direction, okay, then it is going to pull the rack in towards this side. Right. So similarly, if it is going to if the gear is going to rotate in clockwise direction, then it is going to push the rack onto the opposite side. So where we are converting here in this case from rotatory motion to linear motion. Okay. The same thing can be done in the vice versa manner. Now let us assume that the rack is fixed. Okay. The rack is fixed. Okay, and this gear, this shaft can move. So what will happen is that now whenever there is any change in this, now if you are going to slightly, what we are going to do is that if you want the motion to be there, if you are going to slightly move this rack, okay, in the linear motion in any one of the directions, say for example in this particular direction, then this gear starts to rotate in the anti-clockwise direction, where it will move to in the anti-clockwise direction, right? So that means we are converting linear motion to rotatory motion. So in such cases, in some applications, we need this, right? We'll see that later. So this is about rack and pinion. The next thing is called as either a meteor gear, okay, or sorry, we'll go for a bevel gear, not a meteor gear. There are many different types. Okay, one is the bevel gear. Okay, the straight bevel gear. Okay, right. So what is going to happen in this case is that where we have two shafts which are in perpendicular to each other. So if I have one shaft over here and another shaft over here, and we want to transfer power, right, between these two shafts, then we should be able to use a different type of gear for this, which is called as a bevel gear. We cannot use a spur gear or a helical gear for in this case. Okay, right. So in this case, what is going to happen? The gear is going to be, now it's, if you look at this, it's got a circumference, it's got a circular shape. Okay, for a helical gear. Here also it's going to be the same. But when we look any one of this gear in this particular direction, it is going to be like this, like a trapezium shape on which the teeth is present like this, right? Okay, so this is how when we look from this particular direction, this gear will look like. Okay, so they are not, if I look at this gear in this particular direction for this helical gear, it will look like a rectangular shape with teeth present at a particular angle. But see here, it's got a rectangular cross section, but here it is not that. It has got a trapezium shape, right? So it is like a cone. Okay, right. So similarly, both the gears on the shaft, okay, will be like this. So where we can transfer power. So the other gear, okay, will be here like this. So this is also going to be trapezium in shape, and teeth will be like this, right? So if this gear is going to rotate in anti-clockwise direction, then it is going to rotate the other shaft, the gear on the other shaft in clockwise direction, right? So this is about bevel gears are used only for where we want to transfer power between perpendicular shafts. Okay, right. So they're also called as meteor gear, but the only thing is they'll have a curvilinear shape. The gear teeth will not be straight. They'll have the teeth will be in a curved manner. Okay, right. So the next gear that we will be seeing is about the worm gear. Okay. So in a worm gear, what we want, we have again two shafts which are not in the same plane. So we have one shaft here, the other shaft like this, right? And we want to transfer power in the rotatory motion itself. We don't want to convert from rotatory motion to linear motion at all. Okay, so in that case, what do? We have to go for a worm gear. So worm gear will be like this. Let's say, for example, so if it's just similar to a spur gear only, having a circumferential diameter, circumference only. Okay, circular in shape like this. But the teeth on this will be in a different manner. It will be like a curved shape like this, right? Like it will not be straight or it will not be at an inclined angle. Okay, it will be like this in a curved shape, right? So similarly, according to that, the gear onto the other shaft will also be used. Either another worm gear can be used, or the other case is that we can use a screw rod also. So we can use a worm gear. We can have on one shaft one worm gear, on another shaft another worm gear, where they can mesh. Okay, like this. Okay, right? Or we can also have one shaft a worm gear, on the another shaft on the other shaft we can have a screw rod like this. So if the gear rotates, this is going, since it is like a helical manner, okay, the screw that is present on this particular rod has got a helical shape. Okay, so when the gear is going to rotate, even this rod is going to rotate. Okay, right? The shaft is also going to rotate. Okay, right? So this is about a worm gear, right? Okay. Yes, these are the different types of gear that we generally have. There are many more different types of gear. For your extra information, double helical gear or herringbone gear, right? Then we have spiral bevel gear, then internal gear, and many other different types of gears are there. right? Okay. So all you need to know is about the spur gear, then helical gear, then rack and pinion, right? Straight bevel gear or bevel gear, both are same, and a worm gear, right? Right. Just a minute. Okay. So okay, we'll see one more pic. Yes. Okay. So this is how is the when we have uh, another view for this. So if we have the gas, the gear has got different. For on the gear, we have a nomenclature, and that is not required for you all. All you need is to know is that this is called as the teeth of the gear. Okay, so this is one shaft having a spur gear mounted on it. There's another shaft spur gear mounted on it, right? And similarly here also two parallel shafts on which each of these shafts helical gears are mounted, right? Okay, and yes, here we have a bevel gear, so you can see a shaft over here perpendicular to each other, and this is the meshing region, right? And yes, this is a worm gear arrangement. So here we have a worm gear which will have the teeth to be in a spiral shape, in a curvilinear shape, something like this. Okay, and onto the other shaft, if it is parallel shaft, we can have just like this spur gear arrangement, we can have another parallel shaft and mounted with a worm gear. Otherwise, if the shafts are not parallel, they are non-coplanar. Okay, so in that case, we can have a screw rod where these threads on the screw is going to mesh with the gear teeth, okay, of the worm gear. So if this gear is going to rotate, okay, and then this rod is also going to rotate, right? Yes. Now let's see some videos on this. Yeah. So yes, here we have the different types of gear. I mean, spur gear, helical gear, rack and pinion, bevel, worm and worm gear. Okay. Right. Yes. So you look at this. So in between the gap over here is what the if this is one gear, this is one spur gear, this is another spur gear. Okay, when this gear is going to rotate in anti-clockwise direction, it is going to pull this downwards, right? That means the teeth on the other gear is going to mesh or going to fit into this gap. Okay, and so thereby this is also going to be pulled. So this gear is going to rotate in the opposite direction. So this is going to rotate in the clockwise direction. So if this gear is going to rotate in anti-clockwise direction, then this particular gear will be rotating in clockwise direction. Okay, right. So this is about the spur gear. Right. So this is one arrangement. Yeah. Where we can increase the speed, decrease the speed of power transmission from one to another gear. Okay, right? So there is one thing that we have to know is about the gear ratio, how to calculate the gear ratio, right? So one is number of teeth onto the driven gear divided by the number of teeth on the driver gear. So here we are going to calculate based on the number of teeth that is present onto the gear. We are not going to measure the diameter or radius of the gear. Okay, that is only used for belt drives, but not for gear drives. Okay, in gear drives, we will calculate, we will see how many number of teeth is present onto the particular gear. Okay, so if one of the shaft is the driver gear and the other one is a driven gear, okay, so we are going to take the ratio of this. Okay, so that we can find out if this is going to rotate one rotation, okay, how many rotations the other gear is going to make or the other shaft is going to make. Okay, so if this gear is larger, okay, in diameter, that means they will have more number of teeth, right? So if this is and if this gear has got a smaller diameter, for our simple understanding, I'm telling it as diameter, then it will have lesser number of teeth, but the space between the teeth is going to be the same. So if this is going to make one rotation, okay, and if this smaller gear will make more than one rotation, because this is smaller in size in the overall outer diameter compared to the diameter of the other gear. Okay, so thereby what is this speed n1, speed n2, then here T1, which means number of teeth, okay, and T2, number of teeth onto the driven gear. Okay, right. So this is called as the gear ratio that we'll be using. So this is about a spur gear. So you can see the animation of that. Yes, advantages, it's simple in construction, okay, and easy to manufacture, low cost also, okay, yes, and yes, precision is easier to get it. Some disadvantages is that the center distance is limited, that's always there, right? For all gear drives, the shaft has to be not far away, right? But it makes more noise at higher speeds. Yeah. And yes, this is stress means the load on each teeth at a particular time will be more. So yes, so gears are used in our clocks, the mechanical watches, the washing machines, then lathe machine, hydraulic pumps, right? Gear pumps are there, what you can see. Okay, the vehicles also they use, automobile applications. Yes, so next we'll go to helical gear. Yes, so just look at it. Now when we look at this, just look at the teeth arrangement. This is in this particular angle when compared to the shaft. Okay, and this is like this. Okay, so they are going to mesh, okay, at a particular point. So at this particular teeth, in this particular place, with this helical gear is in contact with this bigger gear, but not over here, because by that time this angle is like this, so it would have been left, right? So it's got a different position of contact at each point of time. Okay, so the entire teeth will not be in contact with the other gear. Okay, only a portion of that it'll have a contact, and as it rotates, the contact will slide. It will change from place to place. Okay. So here you can see. So now you can see here in a better manner. So just look at this. See here in this particular case, at this particular point, this particular teeth. Just a second, so that you can see it much better. Yes. So it is only in contact over here, but not in this place. Right? The same teeth is not in contact over here because of the angle, right? But look here, this is in contact over here. This is in contact, but not this teeth. So this portion of this teeth is not yet in contact. Only the other end is in contact. So that is how. So there's kind of sliding action that is taking place over here. So they're a little bit lesser noise here. Okay, they don't make so much of noise. Okay. And the load is going to be distributed onto the gear teeth. Yeah, higher load carrying capacity, smoother in operation, less wear and tear also, because there's almost point contact. Okay, yeah, constant output. Disadvantages is it's costlier than spur gears because it's a little bit difficult to manufacture. Okay, right. Okay, so as it slides, there is more amount of heat that is being generated also. Yeah, it's used in the gearboxes, the gears in automobiles. Okay, then many other applications are also there in the printing industry, in the printers, right, and so on. Next we'll go for rack and pinion. So just look at this. If we have the shaft to be fixed, okay, then the rack can move. If this gear, the pinion is going to rotate, the rack is going to linearly move. So we can convert rotatory to linear motion or linear to rotatory motion. Okay. right? So this is about the rack and pinion mechanism. Easy way of conversion. It's compact because the spur gear can be used generally, cheaper and also. And more noise, friction is more. So yeah, it's used in lathe machines. Okay, there's one particular point where the carriage is going to travel over this bed along the length of the bed. So we have to use the gate trains. Yeah, in many cases we'll have to use this. Steering mechanism is also making use of the rack and pinion method almost. Okay, so now bevel gear, yes. So bevel gear, we have one shaft, and here we have the other shaft. Both are perpendicular to each other. Okay, right. So we can transfer power. Now we need not have the shafts should be parallel. For this case, the shafts should be perpendicular to each other. High speeds and loads, velocity ratio is good. Okay, complicated design and requires more precision. Okay, right. So here you can see one of them. That's actually the place where we have two perpendicular shafts. So in many material handling equipments and all these things, we use this. So worm and worm gear, yeah, this is almost like a screw only. Okay, and here this particular gear will have the teeth like an S shape in a curved manner. So they fit into these gaps exactly. So if the gear rotates, this worm gear also is going to rotate, right? So it can be vice versa. If we rotate this shaft, then this gear is also going to rotate. Okay. So the advantage is that high reduction ratio. That is, we can highly reduce the speed. So we have the gear rotating at a high speed, and the shaft would rotate at a very low speed. So we can immediately bring it down, or the vice versa also. Compact and self-locking feature. It's got a greater amount of grip with each other rather than any other type of gear. Yeah, effective meshing is going to be there. Yeah, so reduce the speed and torque. So some disadvantages: heat at the point of contact, more heat will be developed. Okay, and lower efficiency because it's going to greatly reduce the speed. Manufacture cost is more. Yeah, and high power losses because it's going to reduce the speed. So it is generally used in particular applications where we want only to reduce the speed. So steering mechanism, yes, we use this. Again, in conveyor belts, right? In conveyors to transfer the material. Okay, so in such places we use this. Okay, yes, so that is about the animation of gear gas. Okay, and now let's see about something called as the gear trains. Okay, so let us see about gear trains. Okay, so there are two different types of gear trains. One is just a second. Yes. Okay, so yes. So next we are going to see about gear train. So we can, how do we arrange these gears onto the shaft? What are the different ways that we can, and how to calculate the velocity ratio, right? Okay, so we can transfer power by by either to increase the number of rotations on the other end of the shaft, or to reduce it, and what is the distance between the shafts, all these things. So one of the types is called as a simple gear train, and the other one is called as a compound gear train. Okay, so here what is happening in a simple gear train is that we are going to have the one gear to be fixed on one shaft. Okay, one gear is what is going to be shift on each shaft. We can have any number of shafts which are going to be parallel. Okay, on each one of these shafts we are going to have only one gear. Okay, Okay, so in between the driver and driven gear, we can have any number of intermediate gears. For that, so that we transfer the power from one end of the shaft to the other end of the shaft. Okay, right. So yes. So here is the diagram. So if we have, there's one shaft over here, there's another shaft. On each of this shaft, we have a gear that is to be mounted. So the one which is going to cause the rotation is called the driver gear. The one which is going to receive this rotational movement is called as the driven end, or the gear which is going to receive it is called as the driven gear. Okay, so if this gear is going to rotate in clockwise direction, the driven gear, this is going, driver gear is going to rotate in clockwise direction. Here in this case, the driven gear is going to rotate in the anti-clockwise direction. So the direction is going to be reversed. Okay, so if I want no, now I need the driver gear should rotate. Let us assume in clockwise direction. On the output shaft, it should also rotate in the same direction only. I don't want it to rotate in the opposite direction. Then what do we do? Right? Both the shafts should rotate in the same direction. Then we can go for this type of setup. Okay, where we have one is the driver gear, and at the other end we have the driven gear, and in between these two gears there's an intermediate gear or an idle gear. Okay, so if the driver gear is going to rotate in clockwise direction, then this idle gear is going to rotate in anti-clockwise direction. Since this idle gear is going to rotate in anti-clockwise direction, the gear that is attached to here, the driven gear, is going to rotate in clockwise direction. Now look at this. The driver gear is also going to rotate in clockwise direction. Driven gear is also going to rotate in the clockwise direction because we have odd number of gears, 1, 2, 3, odd numbers. So whenever we have odd number of gears, okay, in a simple gear train, the direction of rotation at both the ends will be the same. Okay, whenever we have even number of gears, okay, we will have opposite direction of rotations. Okay, this is one reason. The other reason is that if the shafts are a little bit far away, okay, and we do not have too much of space, I can have a bigger gear associated like this, and I can have another gear to be placed over here. Okay, right? This can be done, but if there is a space constraint, I cannot use such a big gear. Then what do I do? Okay, so in that case, what we have to do is we have to go in for an idle gear in between the driver and driven gears. Okay, that is another reason why we have to use idle gears. One is to change the direction of rotation. The other one is to transfer power where the shafts are a little bit far away. Okay, so here we have in the third diagram over here we have two idle gears. So here we have the driven gear. Okay, driver gear is over here. If the driver gear rotates in anti-clockwise direction, the first idle gear rotates in clockwise direction. Then the next idle gear is going to rotate in the opposite to that, so it's going to rotate in anti-clockwise direction. And finally, the last gear is going to rotate in sorry, there's a mistake over here. Sorry. So let us assume that this is the driver gear and this is the driven gear. This direction is wrong. Okay. If this driver gear is going to rotate in clockwise direction, the first idle gear is going to rotate in anti-clockwise direction. Second idle gear is going to rotate in clockwise direction, and here it's going to rotate in, yeah, it's correct. Sorry, right? It's going to rotate in the anti-clockwise direction. So the direction is going to be opposite. So the first gear is going to rotate in clockwise direction. The last gear is going to rotate in anti-clockwise direction. Directions are opposite when we have even number of gears. Okay, right. Right. So in this case, now how do you find out velocity ratio? We need to have how many number of teeth is here on this gear, how many number of teeth is over here. Say for example, this is a larger diameter of gear. So let us assume there is 20 teeth and here there is only 10 teeth. Okay. If this is going to go for one complete rotation, okay, right? So 10 gears of this is going to mesh with 10 gears of this for half a rotation. So this is going to complete one rotation. This is only completed half. For the other half, this is going to make another one complete rotation. So by the time this bigger gear is going to make one complete rotation, this smaller gear or the driven gear in this case is going to make more than one number of rotation. Okay, right? So yeah, and what is the speed at which it is going to rotate? We can find out. Okay, so here what we need is n2 by n1 is going to be equal to t1 by t2, right? Okay, right. So now let us take up this case. Now let us assume, now in this particular case, in the second diagram, so this is n1 t1, n2 t2, and n3 and t3. Okay, right. Now let us only take only these two first. What is the velocity ratio formula? N2 by N1 is equal to T1 by T2, right? Okay, so this two gas is over. Now let us go to the next half. Now here N3 by N2 is equal to T2 by T1, sorry, T3. Okay, right? Now if this is going to rotate for one rotation, this is going to rotate, since its size is smaller, it's going to make more than one rotation. Okay, now by the time this makes one rotation, this gear is bigger, the last gear, so it is going to make less than one rotation, right? So there's an interconnectivity between all these three things. So when we equate these, okay, so what is going to happen? Okay, we are going to get it like this. What is the velocity ratio for this particular case? Right? So first thing is that, as I just told you, N2 by N1 is equal to T1 by T2. This is for the first two gas. Then the second and third gas, N3 by N2 is equal to T2 by T3. Now, when the gears are engaged, okay, when the gears are engaged, what is going to happen over here? Okay, finally, what we have, N2 by N1, yeah, into N3 by N2. So this and this will get cancelled. We will have N3 by N1. What is the number of rotations the first shaft is going to rotate? How many rotations the last shaft is going to rotate is what we want. Okay, but that depends upon how many teeth is present here, here, and here. So it's going to be T1 by T2, that is from the first two gas, and then into T3. Okay, right, sorry, what are we going to get? 1 minute. Sorry, here we'll have T2 by T1, T2 by T3, right? Okay, right. So here we have, so actually here we are going to see about the four gas that is present over here. Okay, so we'll see that over here. So here we have N2 by N1 is equal to T2 by, sorry, T1 by T2. Then this between 2 and 3, N3 by N2 is equal to T2 by T1, sorry, T2 by, sorry, T3 by, sorry, N3 by N2 is equal to T2 by T3. Okay, and finally we have N4 by N3 is equal to T3 by T4. Okay, right? So that is what has been represented over here. Okay, for the four gas, N2 by N1 is equal to T1 by T2, and N3 by N2 is equal to T2 by T3, and the gas 3 and 4 are engaged. N4 by N3 is equal to T3 by T4. Okay, as the gas are in series, okay, we are going to multiply all these gas for effective velocity ratio. So N2 by N1, sorry, N2 by N3, okay, N3 by N2 into N4 by, so there's a mistake over here, 1 minute, this must be, this is N1, N2 by N1 into N3 by N2, this particular equation, this multiply all of them is equal to number of teeth for each of this gear, T1 by T2, right? So substituting this, so substitute this, and this, multiply that. Okay, so take that over here. So finally we will get this, because number of T2 and this T2 is same. So here also it's same. So ultimately it is only matters about what is the speed and on the first, that is the driver gear and the driven gear, and how many number of teeth is there on the driver and driven gear. Okay, what about the number of teeth in between is going to be cancelled automatically when we are going to find out the velocity ratio. Okay, yes, we'll stop here for today. Yes.